everybody, and welcome to this first episode of a new era of Talking Kotlin. That's right, we are evolving the show, so expect us experimenting, maybe with a couple new formats, for example, with different folks in different constellations, but all still talking Kotlin. But it still wouldn't be quite the same if I wasn't joined by a lovely, wonderful co-host. So I am very excited to be introducing Marton Braun as the new co-host of Talking Kotlin. Hi, Marton.
Hi, and hello, everyone. Long-time listener, first-time caller. It's great to have made it on the show finally, and as a host, no less. For those of you who have not encountered me at somewhere, I'm a developer advocate at JetBrains. I work a lot with Kotlin Multiplatform, with Compose, and with the related tooling. I also have a background of Android development, which I think is also true for a lot of our community. And I've been using Kotlin since almost the 1.0 of the language. I also love talking about topics like education and open source, so I'm sure that we're going to have a great time with the topics and the guests that we have lined up for upcoming episodes.
There is no doubt in my mind about that. So we decided to actually start this new era with quite a special episode that was recorded under interesting circumstances, right?
Right. So both Seb and I were in New York City recently for Droidcon New York. And so we sat down with Russell Wolf to talk about the conference itself, his multi-platform settings library, and more.
Yeah. I mean, at Droidcon New York, we had a ton of conversations about everything Kotlin with so many people. So I'm very, very excited that we get to share a small piece of that with you. So yeah, let's get into it. Hi, everybody, and welcome to a bit of a special episode of Talking Kotlin.
Where are we?
Where are we indeed? We're at Droidcon New York City, far away from home. And we're sitting down today with Russ. Hey, do you want to quickly introduce yourself?
Sure. My name is Russell Wolf. I've been working with Kotlin Multiplatform since pretty much day one. And yeah, excited to chat with you guys.
Oh, yeah. Awesome. Yeah, this is a little like improvised for us. Like we just decided like after 2 days of a conference, it will be the perfect time to have an in-depth discussion about all the great things that have happened, but also all the cool stuff that that you've been working on. So, I mean, how's it going, like conference impression-wise? How was Droidcon New York City?
It was good. This was a fun one. Yeah, like venue's a little unique. It's a sort of a old-fashioned wedding venue, and has some character to it.
I mean, yeah, it's a special thing for sure, right?
Yeah, it's the first time I've seen something look like this for a conference, but it was a very fun mood.
Yeah, but I mean, I was surprised that for New York City, surprisingly spacious. There's a solid
a lot of space.
Yeah, really accommodates the people, and yeah. So how was the overall like experience in talking to people, chatting with people, and then also how was your own talk?
Sure. Yeah. I mean, I always love Droidcon New York in particular. Like, it tends to be the most Kotlin-y of the Droidcons. Mm-hmm. I gave actually my first ever Kotlin talk, my first ever conference talk here in 2018.
Oh wow!
So it's always one that kind of has a special place in my heart for that.
Very cool. Are you like local here, or are you coming in for the conference?
Sure. I'm from Boston.
Okay.
So a couple hours by train.
Small ways away.
Yeah.
Okay. No, very, very cool. Did you manage to catch any talks yourself while you were here?
Yeah, I caught your talk. Your talk was great.
Oh, look at that. Wow.
Wow.
What a delight. Yeah, I mean, people can maybe look that up as they're recording, if they can find it. But yeah, no, of course, we're all about you here. So what did you talk about at Droidcon New York City?
So my talk was called When Sharing Isn't Caring. And was about, so I love Kotlin Multiplatform, and one of the things I love most about it is the flexibility of it. Mm-hmm. So you have the ability to share lots of code, but it's also very easy to interact with the platform underneath you.
Yeah.
And I see a lot in the community, people kind of really striving for this 100% shared code, mm-hmm. and I wanted to put a little reminder out into the world that like some of the power that you get from this framework is the ability to also do platform native things, to talk to native APIs when they're available, to do slightly different things when that's kind of more natural for the platform that you're running on.
Yeah. I think that was something that we discussed a lot at the booth as well, as we had people coming up to us and talking about KMP, just showing them that you get to choose what you want to share, right? That you can start with one function if you really want to share that, and you can share your entire app, and anything in between also works.
Yeah, I mean, for us, it really seems that a lot of people are really still kind of mind blown by the fact that there's a very transparent way also just to get to the platform.
Yeah.
So when would you say is sharing not caring then?
One of the ways I think about it is like a lot of people are going to start from having like two separate native apps.
Yep.
Mm-hmm. And like there's a tendency to want to say like, oh, I need to switch out all my dependencies for multi-platform dependencies. I'm going to take my take whatever my plan is and turn it into Ktor. And sometimes the better way to start is take your existing implementations that are already like tested, battle hardened, they work, wrap some shared API around them, and like you use that to trigger your platform code from common, but you don't need to re-implement everything. You can kind of keep the working implementations that you have and just get this new native API that you can now call from your common, if that makes sense.
So rather than saying like the go-to way is like just switch out all your dependencies to a thing that's already multi-platform, it's just figure out what interfaces is it that you actually need, and then just whatever you already had prior, you can just still call into that without problem. So there's no need of like switching out the underlying dependency. Is that right?
Yeah, exactly. And like you from the standard library and from the existing libraries and stuff, like you have a nice set of APIs that you can call, and what you're essentially doing is like adding more options to that, and adding more options that are specific to your app and your business and your use case and everything.
Yeah, so if you have like a higher level layer of your shared code, maybe you want to do UI sharing, then you don't actually need to rewrite everything below that layer to be shared.
Right.
You can keep separate business logic, maybe like, as you said, like a networking client that's implemented on both platforms already, and then you can pull your shared UI on top of that. So like flexibility really like goes both ways.
Yeah, and over time maybe you migrate all that stuff more into shared, but you don't need to start from the bottom up.
I'm curious how that was motivated originally, because I mean, like it seems like it's the natural like instinct to want to just go like, all right, well, we'll just switch everything out. Is this something that you encountered in like a project, or that you just saw people try and like not succeed as quickly as maybe with a different approach?
Sure. Yeah. I mean, I've been I've been working with this stuff for a couple years now. Mm-hmm. And so I've definitely seen my share of projects, seen some things work better than others. And like, I wouldn't say that what I'm describing is necessarily the thing that's going to be the best thing for everybody from day one. But the point that I want to make is you always have options. And like, that's, again, like the flexibility is the thing that I love about Kotlin Multiplatform as a framework. So like this is kind of one example, but the idea is like, don't be afraid of dipping into platform-specific code to kind of enable you to do more things from shared.
Yeah. Would you say that it's like hard for people to like actually learn some of the platform specifics then, or like the interface with them, compared to just saying like, well, if I use a multi-platform library, all of that's, at least on the surface level, taken care of for me, right? I don't need to think about it anymore the moment I pull in Ktor. Like, do you see any difficulty there? Yeah,
I mean, and again, it kind of depends on where you're coming from.
Mm-hmm.
So like if you're starting a new app from the ground up, and especially if you're kind of a development team that is more Android focused, like doing things all in Kotlin like can be better, and maybe you do want to like especially for new code, like you often will probably start with KTOR.
I guess when you're starting with existing apps and you already have like
Yeah.
implementations.
Yeah, like that's yeah. Like if you're starting with existing apps and you already kind of have your implementations, like don't throw those away. Like that's one message.
Yeah.
But it's also like sometimes like one of the questions that I see come up on like Slack or on social media all the time is like, how do I do the XYZ whatever something in multi-platform? And sometimes the answer to that is use this library. Like there's a thing already there that does it, but like sometimes that library doesn't exist yet.
Yep.
So what I want to do is kind of empower people to realize like you don't need to say, hey, there's no library here, so I'm done. You can say like your underneath your shared code is these two very mature native platforms. Usually, if there's not a multi-platform solution for your problem yet, there is a platform-specific solution to your problem. So maybe it's like I'm gonna pull in the libraries in my platform sources. I'm gonna kind of do separate implementations using those libraries, and then I'll wrap a common API around that. And now, like, not only have you kind of enabled yourself to kind of do whatever that use case was that you were trying to do, now you maybe have the start of your own multi-platform library if you want to kind of pull that out and publish your own thing.
Yeah, what I really like about looking at adopting KMP from this like other perspective, which I think is kind of the inverse of the usual, where you want, like, usually you would start adopting KMP somewhere on the like bottom layers of your application and like build up from there. But yeah, with this, you have a lot more opportunities to start sharing code, because you can start sharing in higher layers. And yeah, as you said, like keep all of the existing lower layers you have and just wrap them in something that's accessible from the shared code. Like it lets you adopt KMP even if rewriting from the bottom up would be a huge amount of effort.
Yeah.
You can start sharing code where it makes sense to you, for really like your code base, your use cases.
So I've done a little bit of this, like for like a personal side project where, you know, I have like an archive utility for like video, other media, this kind of stuff. And I quickly realized that when you have like conference talk recordings that are recorded in like H.265, those don't really work out of the box, for example, on iOS. So I found myself in this situation where I was like, well, I have some I know that there's like VLC kit on iOS, but I don't really like, you know, there's no abstraction for this, especially if I'm using Compose multi-platform just yet. But, you know, I just decided, I was like, all right, we'll take the plunge and we'll just see if we can call into these APIs. And surprisingly enough, you know, if you have like a dependency from the Kotlin ecosystem, right? You just pull it in as a dependency in your like shared module. And because you get all the headers auto-generated, you are kind of just writing like against like the VLC kit or like AV kit like implementations. But then of course the hard part is always like finding the intersection of like what it is actually is that you can share as like common behavior, right?
Right. Yeah, and there's certainly an art to kind of finding what is the shared interface that I can wrap around these things, especially if you're working with kind of different platform libraries that are implemented in different ways on Android and iOS. If you have kind of an API surface that isn't as consistent, but like I still tend to find like it's one, like I find it like an interesting API design problem. So like it gives me a fun kind of coding challenge, an architecture challenge. But I think like it's generally like that's generally less work than it would be to kind of build the whole thing up yourself from scratch.
Oh yeah. No, absolutely.
The other thing that I'll say about that is especially when you're kind of just doing this in your own app for your own use case, like you don't have to be a perfect generalist from the start. Like you can kind of design whatever that shared API is, like very directly for like what is the exact call that I need to make from my shared code and what is the exact input that I have at the time or whatever.
Yeah.
Not this exact topic of multi-platform, but something very similar happened API design-wise with web views, I believe, where Google had this accompanist library for web views, which aimed to wrap the existing Android view, web view into a Compose API. But then web views are so complex and they have so many options, and they were trying to design Compose API that manages to delegate all of that into the original implementation. And they essentially removed that components library eventually, and they said, please just implement it like in your own apps. Channel in the options that you do actually need. Like if you need the flag to disable JavaScript, if you need this flag, that flag, you can implement that. But providing a general solution is just not feasible. It's not good for anyone. So yeah, sometimes that's how that goes. If you're at the app level, there's a lot of things you can afford API design wise.
Yeah, and
which is nice.
It's one of those things where I kind of got my start in Kotlin Multiplatform a little more on the library side, where like I got used to kind of thinking a lot about like trying to be general, or trying to like make sure you're open to different use cases and things. And it can be a nice shift of mindset to remember, like if I'm building an app, I just need to do what my app needs to do.
Yeah.
Should we talk a bit about the library?
Well, I was about to have like a really nice segue, but now I guess we're.
Was that not a nice segue? I'm sorry.
That would have been a nice segue. No, like,
okay. Do yours as well, and then we'll compare later.
Okay.
Leave a comment about which one's better.
Well, I just wanted to pick this up again briefly from this like media player example, because of course like the first thing the first thing that I typically do always is I just like spaghetti things into what I already have, because I'm like, let's make it work first of all before we add additional constraints. But then the natural next step typically is like, you're like, all right, like I can extract this into just like its own like Gradle subproject, like its own Gradle module. And first of all of a sudden you realize very quickly that when you no longer have access to like a bunch of random state and symbols from your own app, you all of a sudden either have to pass a lot more parameters, or just like re-architect your APIs. But I guess it also like directs you to, first of all, writing things in a cleaner way, and then also kind of prepares you to package something for like actual reuse for the second time that you might be able to use it, or then at some point that the community can be able to use it.
Yeah, definitely. And I like one of the things I've always found with Kotlin Multiplatform is like you said, like you do kind of naturally find yourself doing the same sorts of things that you would do if you're just trying to architect things cleanly and have clean separation between layers and stuff like that. Like you're kind of having common versus platform source sets kind of naturally gives you that layer separation.
Yeah. Well, with that, now you get to do your segue.
This is all staying in, I hope. All right. So can you tell us a bit about the library work you have been doing as a valuable member of the community and a great contributor to the ecosystem?
Sure. Yeah. So I maintain a library called multiplatform-settings, which is a key value store for Kotlin Multiplatform. So it wraps around things like SharedPreferences on Android or user defaults on iOS, as well as a number of other APIs on different platforms, and lets you access that functionality from Common. So if you have, just kind of simple little bits of application data that you want to save.
This maybe is a very simple question, but like, where did that like come from? Why did you decide to build this?
Sure. Well, it actually started from like the very first ever like demo proof of concept multi-platform app I tried to make. I was we had kind of a skeleton starter project at the company that I was working at the time. And I tried to translate that into multi-platform. And one of the things that app did was talk to SharedPreferences. Mm-hmm. So I said, well, if I want to get this working on iOS too, how is that going to work? So I had there was a little bit of logic in there to talk to SharedPreferences on Android, talk to user defaults on iOS. And I as I was doing that in the app, I started to think oh, well, this seems like a useful thing that people might want to use. It's sort of a thing that I knew would exist eventually. Mm-hmm. And this is literally at the very beginning of the Kotlin multiplatform world. It was 2018, there were no libraries at all. Coroutines did not. Coroutines was still experimental and didn't have multi-platform support yet.
All right.
I think like serialization might have been out by then, multi-platform serialization. But like there wasn't much there, and I knew someone would write this library eventually, and I figured I would try to be the one to do it.
Can we talk a bit about the platforms that your library supports? You said Android and iOS, and
so
what else is there?
I try to hit a bit of everything. I like the way it's structured right now is there's a core interface called Settings that's published to every platform, but I don't have implementations of it on every platform. I have at the moment there's a couple options on Android, a couple options on iOS, a couple options on JVM. All of the iOS stuff also works on other Apple platforms. There's a Windows implementation. Right now, there's nothing on desktop Linux. That's one of the things I would like to add, but I haven't. I'm not a Linux programmer by trade, and so one of the things that's been difficult is kind of figuring out what is the best backing API to use.
So that's just a matter of like where to actually like store the data.
Yeah, and there's options. Like there's a couple different like libraries and things that exist that do essentially a key value store. But like one of the kind of design choices that I made for this library is I want it to you could write a key value store that's just kind of build a new thing from scratch and you do all your own file system management and stuff like that. But one of my design goals was interop.
Yeah.
So I want you to be able to talk to the same API from your shared code that you might already be using in pre-existing platform-specific code.
I mean, that makes sense, right? If you have a setting, it would be good that any pre-existing Swift code, for example, would also be able to see that setting.
Yeah.
So like if you have existing logic that's talking to user defaults on Swift, you can use that same source of truth in your common code, and it can be talking to the same user defaults instance. So I don't know. I don't know what kind of the best API to use on desktop Linux that would kind of have those same properties. But I would love to hear about that if anyone in the community has ideas.
Yeah, it's hard to imagine like what options you can find for storing on like some platforms, like on the web or like on desktop. I imagine you can always store in just plain files in some format if you want to, but I don't know if there are other options available. You said there's a Windows implementation that you have?
Windows actually stores things in the registry, which is one of those things that like sounds a little bit weird, but actually like one of the intentions of the registry is as a application settings store, and it essentially like it has some weird types in it and in a weird kind of tree structure to it that I don't make use of as much, but it is ultimately a key value store, and I can kind of use that in the library as well.
That makes sense. I feel like I have to try that for fun now. Just store some things with that Windows implementation and just find it in the register tree.
You can.
HKey local user or something.
That sounds super exciting. That's very fun.
So this actually maybe it's a good point to pick up with another question, which is, I mean, on the surface, all of this, I mean, it's a key value store, right? And you're like, well, where's the complexity come in, right? Like, why? Like, surely it's just like forwarding an API call here and forwarding an API call there. But clearly, there's like more to it, right? So, is there like just generally some inherent complexity, or like, was there any challenges you faced while like building this?
Yeah, I mean, like it's obviously it's not as complex as some other things.
Sure.
But there is a surprising amount of kind of subtlety, like to the API choices that you can make. So, SharedPreferences, for instance, you have setters and getters for a couple different types. Anytime you do a get call, you pass a default value that will get returned if there's no value stored there.
Okay.
But
so on every call.
Yeah.
Okay.
Because you need to return something.
Yeah, like you need to return something. This was a Java API that didn't have nullability baked into the API design.
Sure.
But like you could instead return null instead of you would obviously return null instead of returning a default value. My initial API was much closer to the SharedPreferences version of it. Now you have options, so you can do get with a default value, or you can do get or null, and it will return null by default.
Okay.
Yeah. I feel for this very strongly. I wrote a library at some point to wrap shared preferences into delegates, so that you can just delegate a property into shared preferences, and then reading and writing that would do the I/O, which is not great because it would be nicer to do it with coroutines asynchronously and so on. But yeah, I ended up fixing shared preferences the exact same way, giving the nullable option or the default option, because the way that it's implemented has like some legacy built up for sure.
Yeah, definitely. And I actually do have a similar delegate API in multiplatform settings.
That's very cool.
As well as like a couple other nice syntax things. So there's like some operator overloads that you can do, like the bracket syntax instead of doing the get call and things like that.
Did you run into the problem of like wanting to have a suspending delegate yet?
I sidestepped that by not trying to. Though I do. I do have there. It's still marked as experimental for the moment, but I do have some APIs that are like a suspending and flow version of the whole settings store rather than the default synchronous one. And one of the big reasons for that was I wanted to be able to also integrate with data store, which didn't exist when I started this library, but is now kind of another multi-platform key value store. And in order to like use that as a backing storage for multi-platform settings, I didn't want to just be hiding run blocking everywhere. And so I kind of added these suspending alternatives so that you could return suspend functions or flows instead.
And again, if we're looking at the timeline again here, with coroutines just kind of coming out the same time as you were kind of constructing this, I guess you were really on the forefront with this stuff as well. And then like, was it just like the flows came out as like a preview, and you were like, all right, we can fit this in here? Or?
No, I didn't really think about it until Data Store came along. Actually,
okay.
Yeah, obviously you might want suspending versions of things just because you are talking to storage, and that can kind of take a little bit of time sometimes. But I didn't really start thinking about like actually shipping a suspending version of the API until I had a delegate that I wanted to wrap around that would need it.
And then with flows, the other feature that you would have is observability, right?
Yes, which is another interesting thing. So there's because some of the APIs that I wrap are observable and some of them are not. And so that ends up being kind of another point of differentiation sometimes. So there's a settings interface that's just kind of the default thing, and there's a observable settings that adds some update listeners.
So, but if again, looking at the typical case of like Android development and iOS development as a shared case, do both of them have an observable version, or do I just?
Yes, so both user defaults and shared preferences do, and obviously data store, if you're using that, is already using flows. The one that's tough is there's also a implementation in iOS that's backed by the keychain. So if you want a more secure storage, and that does not have the observability.
Oh, okay, all right. So that means the observable version just doesn't exist, or you're like have like a polling implementation for it, or?
Right now it doesn't exist. So one thing actually that I added to the library recently, based on some feedback I was getting and a contribution from someone whose name I'm forgetting right now. I'm sorry. Is a thing that does that kind of manually wires in update listeners, and so rather than depending on the platform to push things to you, it will just register a callback every time you make a change. So it has some limitations in that if you have kind of multiple instances of it, they won't be able to observe each other. But if you just have kind of one singleton store in your app, it can be a nice way to get that observability on platforms that don't have it by default.
Oh, nice.
You brought up something interesting with keychain. That's a more secure form of storage. Do you if you want to like encrypt the things you're storing, or I don't know like in what way it's secure, but do you have options to customize the instances that you create on each of the platforms to go for something more secure?
Yeah, so you are almost always kind of passing in a delegate from the platform. And so like on Android, there is shared preferences, and then there's the security library that includes encrypted shared preferences. So I didn't have to do any extra work to be able to support you passing that encrypted version. So not every platform has kind of an obvious default thing to use for that.
Yep.
But I've tried to design the API in a way that things are flexible so that you have those options when you need them, and so that you can like if there's something that you need that the library doesn't give you, you have the option to build it and provide it yourself.
Okay. All right. Well, the spicier version is there like an encrypted registry on Windows or?
Yeah, there's only one implementation that I ship with on Windows.
Okay. Fair enough.
I wanted to ask earlier if the registry notifies you of changes, but I felt like we need to let go of the Windows topic.
There actually there is an API that will do it. I don't have that implemented in the library right now because it's a little bit complicated. Like these are all very funky APIs to work with, especially when you're working through the C interface when they do using more C++ or C# kind of stuff.
That actually means that like your library's implementation is probably like a very interesting sample for people to look at of how to bridge out into all of these various platform specific things.
Yeah, there's a lot of interesting little bits of doing some of the like C values and pointer and that kind of stuff. Yeah, both like the Windows has some interesting stuff. The keychain has some interesting stuff. I have some. I was mentioning Linux before. I don't have something that ships right now, but I have a couple draft PRs with kind of some ideas. So there's some interesting stuff in there too if you're doing kind of weird zany native pointer things.
But I think it's also like it's a good like reference to kind of look at for people who are maybe like building their first like multi-platform library, because it does kind of like tackle these like typical points that you have when you're first building multi-platform. Because it's like on the surface level, of course, everything's like pretty easy in Kotlin multi-platform, because the main abstraction is like, well, you have like an expect actual, like for the main part, an expect actual function, and like pretty much everything else you kind of build on top of that. But then, you know, the questions start popping up when maybe there's two implementations on a given platform, and all of a sudden you're like, well, wait a second, I can't provide two actuals for like one expect.
That was actually a big piece of early learning for me. Was like at the beginning I had like an expect class settings, and that was the core of everything. And I ran into that exact problem. I wanted to like I could write my own tests in the library against those implementations and kind of do my own setup and stuff. But if you were an application developer wanting to test your code that was interacting with multi-platform settings, there wasn't an easy way to kind of mock that out. And so by switching settings to an interface, I was able to also provide a map-backed implementation that's just in memory. And so when you're kind of writing your test code of your application, you can inject the map settings rather than the platform one.
Okay.
And then that highlights like really nicely just how many things you need to take care of as a library author. So there's a lot of API design questions. There's, you know, people who are going to be asking for the encrypted storage. And yeah, there are going to be people out there who test a lot of their code, thankfully. Okay. And very often you need to consider how your library being embedded in someone else's code is going to remain testable.
Yeah, and there's like it's a funny thing because like a lot of people in the Android community historically have like there's a big segment of the developer population that likes using things like mocks in their tests, and that works on the JVM, but there's not really good ways to do it on the other platforms, and so there's not really a good kind of multi-platform mocking solution that can work for final classes and things like that. And so I like both my library and many others I've seen tend to have kind of some functionality to put a fake implementation in place when when you want to be able to run tests without actually touching the disk or touching the internet or things like that.
Yeah. But also, like, so one of the things that I remember. Okay, so first of all, so in this scenario, can you still have the kind of the entry point to settings in your common code? Because obviously, like, you're now looking at a situation where you have platform specific like details that you kind of like need to have to probably construct the object. But like, I think the natural urge is always still to like, I'm thinking of like, Ktor, right? Like in Ktor, I can create an HTTP client with just no arguments in common code, and then it'll figure it out. Like it'll just figure it out based on whatever dependencies I've added or that I accidentally added to my class path through the transitive dependency. But it'll figure it out. Like, how do you approach that?
Yeah. So at the beginning, I just focused on being able to configure it from your platform code.
Okay, so just to understand, in this scenario, there's some Kotlin code that's platform specific.
Yes.
And then you would call that from each entry point, like from each each platform specific code.
Yeah. So like often in practice, you'll have maybe some kind of either a dependency injection library or just some kind of entry point to your app.
Yep.
And one of the dependencies that you would supply at that entry point is the implementation of either the settings implementation directly or the delegate that you want to use.
Okay.
And then and one of the nice things there is like if you had an instance that like existed in your Swift code on iOS, like you could pass that in from the application layer.
Ah, okay.
But over time, I did get the feedback from people about wanted to be able to kind of just do everything from common. So there's a separate module that I added called noarg that gives a settings factory function that takes no arguments and just uses defaults for everything. So if you do want to, like if you don't care about the details of the configuration and you do want to just be able to do everything from your common code, you have that option too.
And in that scenario, it just picks like a hard-coded implementation, or like do I add a specific platform-specific dependency, like with the Ktor engines, like one of them, and then it'll pick that one, or
it's adding it's a hard-coded version, so it's kind of most things have like a reasonably consistent default that makes sense to pick. Android has this like preference manager .get default shared preferences. iOS has like the normal user defaults .shared. JavaScript uses local storage, and there's just one instance anyway.
Yeah, I used that recently in a workshop as an example, and I was quite surprised myself to just be able to do like local storage .put and get, and like that's the entire API surface. It's like, oh, that's kind of neat.
Yeah.
With the I mean, we've seen this a little bit when we've done like some live coding with Room and such, right?
Yeah, Room is also, doing I/O. It has to store its database somewhere.
First of all, the Room is now multi-platform, and just to reiterate that bit.
Yes.
That's a pretty cool thing.
Yes, Room is now multi-platform. You can use it for SQL-based storage with really nice code gem features.
Yep.
It also supports encryption with SQL Cipher, which we learned like yesterday.
Yeah.
Again, here at the event, which is great. Yeah. And so Room has to store the database file somewhere. So it kind of forces you to have a platform-specific bit of implementation that specifies the path of where to put that file. And maybe they could find a similar approach of finding a default location for that. I don't know how trivial that is for the like iOS file system. For an Android app, it seems doable. iOS, I'm not sure.
Yeah, I'm trying to think, like, because there's also SQLite is another multi-platform SQL library, and they don't have anything like this. They just have platform-specific configuration, where you pass in a database name and stuff.
Wait, for SQLite, I need to pass in. I need to have one constructor or like one factory per platform.
Yeah, you pass in a platform-specific factory or platform-specific engine.
I'll be honest with you. SQLite, interesting enough, I only used for like a microservice thing that I've built on server side, which is a little like atypical. But that was all JVM, so I didn't really touch the multi-platform bits of it.
Yeah, it's another one of those it was one of those libraries that was available very early on. So I got used to it and it, got using it very early, and I'm a big fan. I like the way that it kind of keeps your SQL as a sort of truth and lets you doesn't hide it from you in the way that some other kind of ORM libraries sometimes do.
Yeah. No, I mean, SQLite is pretty neat.
Yeah, it's fascinating seeing this over and over, where the community is usually very quick to build solutions for all of these gaps that they see in the ecosystem. And then we also see, for example, all of these established Google libraries slowly moving over to the multi-platform ecosystem. And, we all have more choice. You can use the familiar library. You can use a library that was designed with multi-platform in mind from the beginning, so it might provide a better experience in some areas. It's very nice.
Yeah. I mean, I have to personally say, so I'm not super big on DI frameworks in general. Like, if I can avoid them, I'd rather do that. But I have to say that with multi-platform, for example, working with Coin is very nice, because you can, once again, you have this typical pattern where oftentimes you need to inject a little bit of platform specific constructor logic for each platform. And as you add a second library next to multi-platform settings or next to room and so on, it's nice having a kind of centralized place to do that and not having to touch each entry point every time. And rather than that, just call init coin at each entry point, and instead just specifying different module definitions per platform. So if I think that might be also a good avenue for people to explore if they're playing around with this. It's maybe one of those bits that, I mean, if you're looking at, I think, the official Room documentation, I don't think they mention much about multi-platform dependency injection. They'll just tell you, well, here's the 3 functions, you gotta call them on each of your 3 platforms.
Yeah, given that there's no Google written DI library for KMP yet, although a lot of people are asking for Dagger naturally, including asking us for multi-platform Dagger, which is great.
Yeah, there was a talk at the conference today about Kotlin Inject, which is another DI library that's kind of designed in a way that it looks very familiar if you're used to Dagger.
Yeah, but it's multi-platform.
But it's multi-platform. Yes.
I mean.
Yeah, that's the go-to library that we point to when someone comes up to us and asks for Dagger. We often mention Coin because it's clearly the most mainstream library at the moment. But there are very valid alternatives. There's maybe 3 different DI frameworks that are quite popular, just in terms of GitHub stars and user base like that. If you want something that looks more like Dagger, because you're used to that style, maybe you're migrating from Dagger, right? That might be easier.
Yep.
Yeah, and it's one of the things that I love about the state of the ecosystem now is it's gotten mature enough that you have all of these use cases where there are multiple options and you can pick the one that works best for you.
Yeah. I mean, one of the reasons why we've also been shouting out Coin every once in a while is because they've moved very rapidly when it came to the entire composed multi-platform story. I mean, we've introduced the architecture components recently, right, for multi-platform, which includes view models, right, and being able to use your dependency injection framework together with your with the view models that are now multi-platform. I mean, I think they had an implementation but we didn't even announce it yet. I think when I was at KotlinConf on stage, I think I already had a slide that mentioned the fact that Coin supports them, which, I mean, that's pretty mind-blowing. So that's also something definitely worth checking out. Are you aware of any large or deployed projects out there that are using multi-platform settings that you're allowed to shout out?
I don't know if I can say that I'm who I'm allowed to shout out or not, but I mean, I've definitely worked both had projects that I've worked with that it's in and had have had people let me know that they're using it, which is always a nice feeling.
Yeah. No, I mean, I think the community response and the stars on GitHub and everything, like, clearly showed, like, pay testament to that.
Sure. Appreciate that.
Yeah, all right. Well, Russ, it was absolutely lovely talking to you. Thank you so much for after the 2 days packed with conference talks and chats and talking to people at the booth and so on. That you took the time to chat with us today and share a little bit with the wider Kotlin community here again. So really, thank you very much for being here.
Yeah, thank you for having me. I had a great time.
Yeah. And of course, everyone who decided to tune in today, thank you very much. We will be returning with probably more regular, like typical episodes in the future. So that's something to look forward to. I hope you enjoyed this special one. And we're probably going to try and combat whatever of our jet lag remains. At least I still have some left. But yeah, it's a great time. So yeah, thanks everybody and take care.
Bye.